Hello dear students. In the last lecture we have seen the network flow, and in this session we are going to look at an important application of network flow. This is called maximum bipartite matching. A bipartite graph contains two separate groups of nodes. For example, imagine we have students on one side and projects on other side. A student may be interested in only certain projects. Our objective is to assign as many students as possible to projects, with each student and project being matched only once. This is a matching problem. Instead of solving it directly, we can convert it into a maximum flow problem. That is the interesting connection between the two topics. So matching using maximum flow. Now look at the graph on this slide. We add a new node called the source. So the source is connected to all nodes in the first group. Then we connect the first group to the second group according to the possible matches. Finally, all nodes in the second group are connected to the sink. We give capacity 1 to this edges. Why capacity 1? Because one student can be assigned to only one project, and one project can assign to only one student. Every unit of flow represents one successful matching. Therefore, maximum flow equal to maximum matching. This is a very useful technique because a difficult matching problem can be converted into a standard network flow problem. Then bridges and bridges and local bridges. So now we move from network flow to another important concept in social network analysis. Suppose we remove one particular edge and the network gets disconnected. That edge is called a bridge. If there is only one bridge between the islands and we remove it, the two islands can no longer be directly connected. Now we have another important concept called local bridge. When we remove a local bridge, the network may not become completely disconnected. However, the distance between the two endpoints increases. So remember, bridge disconnects the network. Local bridge does not necessarily disconnect the network but increases the shortest path distance. This is the bridge and the local bridge. So and the next one is strength of ties. Now let's connect this idea to social relationships. Not every relationship in a social network has the same strength. For example, your relationship with your parents or close friends is a strong tie. Your relationship with someone you met at a conference or someone you occasionally interact with may be a weak tie. Interestingly, weak ties can be extremely important. Why? Because they often connect two different groups. Imagine one group of computer science students and another group of business students. A student who knows people in both groups acts as a bridge between those communities. Information can travel from one group to another through this weak connection. The next one is strong triadic closure. So look at the three nodes in the diagram. Suppose person A has a strong relationship with B and A also has the strong relationship with C. Then there is a good possibility that B and C will also know each other. This creates a triangle. If a person has strong ties with two people, those two people are likely to have some relationship with each other. This concept helps us understand friendship formation, social communities, relationship patterns, network structures. So when you see a triangle in a social network, think about the relationship among all three peoples. So then bridges and tie strength. Now let's connect the previous two concepts. We have already seen strong ties, weak ties and local bridges. Look at this network. Suppose two groups are densely connected internally, but there is only one connection between the two groups. That connection is likely to be a weak tie. and may behave like a local bridge. Why? Because removing it makes communication between the two groups much more difficult. This is an important idea in social network analysis. Strong ties generally connect people within the same community. Weak ties often connect different communities. Therefore, weak ties can play a very important role in spreading new information across the network. So the generalizing to real world networks. Now let's think about the real world network. In a real world social network, we cannot simply say this relationship is strong or this relationship is weak. We need some way to measure tie strength. For example, consider a mobile phone network. We can measure the strength of relationship using number of calls, total duration of calls, frequency of communication. If two people communicate very frequently, we may consider this relationship stronger. Now look at the concept of neighborhood overlap. We compare the neighbors of two connected people. If they have many common neighbors, their relationship is probably within the same community. If they have very few common neighbors, their connection may be acting as a bridge between two different communities. This gives us a quantitative way to understand network structure. So the next one is bridge detection. So why do we need to identify bridges? Because bridges are critical connections in a network. Imagine a transport network. If one road is the only connection between two cities, that road is extremely important. If it fails, connectivity between those two areas may be affected. Similarly, in a computer network, a critical communication link can affect a large number of users if it fails. In a social network, a bridge can connect two different communities. Therefore, bridge detection helps us identify critical connections, improve network reliability, find vulnerable links, understand information flow, analyze social communities. So when you analyze the network, don't look only at the highly connected nodes. Sometimes one single edge connecting two communities can be much more. So then we started with the network flow, where we studied how flow moves from one source to a sequence with capacity. Then we have flow network flow capacity, then flow conservation, then residual network, then automatic flow, then flow filter, and then transfer. Process flow transfer, then transfer, so finally, the most important thing is how to operate this system. So you have to understand the functions. So nowadays, it's that is the is not that is what is the capacity which one and where connection. And this social network, which connection connects which it is a. So once if you start asking these questions, network analysis becomes much easier. So thank you, students.